Welcome back to part 4 of our series on random forest. So whole purpose of this series is we're going to create a random forest model that will help predict whether a stock will close up or down in future days based on historical indicator calculations and price information. So the whole idea behind this is we're basically recreating this research paper that I found online. I thought was really useful. I know a lot of people inside my channel who love finance, and so this was a great way to get the data science people, the finance people, all under the same umbrella and do some machine learning. So in our previous video, we were focused entirely on calculating indicators, so that's good. We got that all out of the way. So now we have basically this massive data set that has just bunch of rows and bunch of information in it. Now, for our purposes, we actually don't need to pass through everything to the model. To be completely honest, I don't know exactly. Oh yeah, I guess they're just doing that one. We're just going to be kind of passing through some stuff. Oh, that's kind of interesting. We'll talk about that in a second. But yeah, so we're just going to be passing through a couple different columns. But what we first have to do before we actually feed this data into our particular model, we do have to create our prediction column. So basically right now, there's nothing here that is, well, this is from the old one, but there's nothing currently in our data frame from the one up above that basically defines whether it's part of class 1 or class 2. So, class 1, being a down day, class 0 being an up day, for example. So, down is 0 and then up is 1. So we need those ones to basically help us predict. So what we need to do is create that prediction column. So how do we do that? Pretty straightforward. We can actually take some of our code up above. It's actually pretty straightforward at this point. I'm gonna take this one right here. So we're gonna do our similar group by, and then we'll just call this, something, like closed groups. So we're gonna group by symbol, and then we're gonna grab our close column. So we need that one. And then we're going to apply another lambda function, right? So we're gonna apply another lambda function. So we're gonna take our closed groups and we are going to do a transform. And then we're gonna be doing lambda x. We're gonna do the shift method. So shift 1. And we have a simple rule. So if the one that is above us is, if the one it's currently greater than us, then what we're going to do is it's just going to return a true or false, right? So this is just basically a comparison. So we're just saying, hey, is the one down, is that less than the one that was above it? If it is, then return true. Otherwise, leave it the same. And so when you look at this, hopefully we'll kind of get an idea. So we'll see like, okay, so this kind of makes sense. So, if we had to be exact, okay, so this is down. Okay, that makes sense so far. So if it's false, it means it was basically a down day. And then if it was up, it should be true. And so what I need to make sure though is I can't pass through a Boolean value necessarily into my random forest model. So I need to make sure that I convert it first to something that it can handle. So the first thing I'm gonna do is I'm gonna create a new column called prediction, and that will equal my closed groups. And then I'm just gonna times it by 1. And so if I do that, it will just convert all of that to numeric values. And so that's a little bit easier, and you can see here, so that's good. I don't know if this is exact. I'm gonna have to read through some of this again to make sure I'm doing the naming conventions right, because I got mixed up initially when I was first doing it. So, but yeah, so zeros are our down days, and then up are our 1 days. And so this is what we're trying to basically group. So we're gonna say, oh, well, this belongs to the down day group, this belongs to the down day group, this belongs to the up day group. So this is creating our particular group label, if you want to think about it. This is kind of that classification component. Now, something I also do want to have for people, again, it's just kind of optional, so I'll just put optional. At this point, if you wanted to, you could dump your code. So you could do something like price data CSV, sorry, not CSV, to CSV. And then what you could do is you could just give it something like, I don't know, final metrics.csv. This is just a way, again, if you want to explore it yourself, go right ahead. At that point, I think it's more than reasonable to, hold on one second. Sorry, something got kind of mixed up. You could just dump it to a CSV file and you should be good to go. So this is just a way, again, if you wanted to, you could go through it and, just organize it all. So really useful stuff. Okay, so now that we've done that, this next part, you don't need to technically do it. Random forest can actually handle missing values. It is possible. It does its own little process behind it. But for me right now, I am actually going to remove our missing values. This is just more related to our indicator calculations because technically some of them wouldn't be correct if you don't have X numbers of days available. So, you can't necessarily take its value. And so it's pretty straightforward. I'm not doing anything too crazy. I do want to make sure that people kind of see it though. So you can do it. So I just print out beforehand the shape. So I tell you the number of rows and columns. And then I tell you, hey, after we do all the dropping, how much, do we have? And so once we do that, everything still looks exactly the same. So it's good, but now we don't have any missing values. So that's kind of the important part. So this is just removing the missing values. Again, you don't have to do that technically. You could actually feed in missing values to a random forest model, but for indicator purposes, technically some of those wouldn't be right unless you have a certain number of periods. So me personally, I don't really feel comfortable passing it through, but you could try and see what you get. And if the accuracy really isn't that different, hey, maybe it's not really kind of worth it to do it. So just some things to think about when you're doing this yourself. Okay, so now that we've done that, we need to select our columns that we're going to be using inside of our model. So we're going to be using the RSI, the K%, R percent column, price rate of change, MACD, and on balance volume. So there's going to be our X columns. So we're going to create a new variable. We'll call it X columns. We're going to take our price data frame, pass through a list. Here's the fun part, me trying to type and making sure it's right. K%, R percent, price rate of change, and then we need our MACD, and then we need our on balance volume. Okay, so that's our X column. Then we need our Y columns, or column, but we'll just keep it like that. In this one, in that case, we're going to do a prediction. So our Y column is our prediction. Oh, I know I did something wrong. On balance volume, not in. Oh, no. Balance volume. Great. So hopefully nothing's crazy. Good. Looks good. Everything looks good so far. Okay. Let me see what they have here. So this is how they're so we're basically just doing with them. So they take the stochastic one, our MACD percent change. This was kind of interesting. It seemed like they were doing 60 because I looked back, I said, oh, that's interesting, but I don't know why they did. I mean, unless I'm reading the label incorrectly, which is completely possible. So that was kind of interesting. And then they also didn't include the EMA of the MACD. So that was kind of curious. I understand they're calculating the MACD, but it doesn't seem like they were leveraging that whole signal component. So be kind of curious to see if you add that in, if that would make it more accurate, less accurate. I guess it kind of just depends. That's kind of just food for thought. Maybe if you want to kind of test and say like, hey, if I add it in, does it improve it? Does it make it worse? There's probably multiple reasons, they maybe left it out. So now that we've collected our data, we need to test it. Split it into a training and testing set. I'm kind of following what they did. So they didn't actually specify any specific split. So they just use the default values that were provided by scikit-learn. And so they did specify the random state, I think it was 0. So they just used the random state generator. But this one, yeah, I mean, they didn't specify it. So again, I'm going to try to keep certain things close to theirs. Other ones we'll kind of keep it the same. But this is just splitting our training and testing set into 2 different components. And so now we're going to have an X-train component. We're going to have a Y-test component, X-test component, and a Y-train component. So these are all what we're going to be using to feed into the model. Okay, so now that we've done that, we need to create our random forest classifier. So we're going to do random forest classifier, random forest classifier. Okay, so here's the fun part. We'll get a little bit more into what these arguments are. The first one is n estimator. So this is the number of trees in our forest. We are going to be looking at something called the out of bag error score. I'll kind of give you some context as to what that is and when you maybe shouldn't use it, when you should use it and stuff like that. And then our criterion is the Gini coefficient. And then our random state is going to be 0 as well. So number of estimators is the number of trees, the out of bag error score. Again, we'll talk about that when we get there. And then we're going to be basically the criterion for splitting is the Gini coefficient. The Gini index too. So this is just, again, I'll kind of get, when we get to that point, we'll talk about it. But basically this is going to be how it decides how to split our trees. And so there's this whole concept of information gain, impurity, and things like that. And so this is just telling the model, hey, when you do split it, this is how I want you to split it in X, Y, Z. So this is basically just defining our random forest classifier. So now we're going to fit our data to the model. And so we're going to take our random forest classifier, and that's going to be fit. And then we're going to take our X train and then our Y train. So we're going to fit our data to the model, and then we're going to make some predictions. So make predictions. This is always the funniest thing about this whole machine learning process. Literally, to make the model is a few lines of code. Getting everything set up and all that, that's a whole different beast. But it's just interesting. I think it's really interesting that we've gotten to that point where you don't even have to really pass through that much and you can get a pretty decent model. Okay, so we got our X test, and so we're going to pass through our testing. So from this point, we can start kind of evaluating at least initially. I want to make sure I'm kind of following this. This is kind of where my printing job got all messed up. Okay, so this is basically our model has been trained, if you want to call it that. So now we can start the evaluation process. So trying to think how I want to approach this. We'll talk about accuracy first, and then we'll kind of go into some other stuff. So one of the ways that we can evaluate basically how well our model performed is something called accuracy. And so this is basically just saying, hey, on basically how often were you correct? So naturally you want a higher accuracy. If you have a higher accuracy, that means it was correctly classifying information and it wasn't incorrectly classifying information. So there's a little bit more to the story than that, but at this point, it's just a really kind of easy way to say, hey, how well did you do? So out of the data that we gave to you, how well did you perform? And so I have a nice little component. And so this is just going to print out the accuracy. And so if you remember all the way up above, there is a metric that I imported from sklearn called accuracy score. So right here, and then there's classification report too, but we'll get to that in a second. And it's just going to be used for evaluation purposes. And so all that expects is that Y test component and then that prediction. So I mean, technically I could have just passed through. This is again some older code. So I can just pass through my Y prediction, my normalized. This is just saying I want it in terms of percentage. Otherwise, it gives you an absolute value. So like, oh, well, we made like, 36 correct predictions. I don't want that. I want more in percentage terms for accuracy purposes. So you look at that and you go, that's not bad. I mean, you're saying 70% of the time it's correct. I mean, that's pretty accurate. And I was kind of surprised when I first saw that because normally it, I mean, at least with certain stock market models, I mean, it can be much lower. So the fact that we were at 70% was, I mean, pretty impressive. But, at the same time, you got to kind of also look at it from certain terms too. We're just looking direction. We're not saying like how high is it going to go, how low is it going to go. It's just saying it's going to close up or down. So while, yeah, it's pretty accurate, you got to take that kind of with a grain of salt and understand that there is this component now where, okay, if you were using this for like a trading strategy, you can still have some pretty interesting volatility during a day. So knowing that, your strategy, in my opinion, would kind of have to adjust to, understand that you're taking your positions correctly, that in essence that, it makes sense to carry your positions overnight or things like that. It's interesting because you're saying, hey, it's 70% of the time it's able to tell. So based on that, what does that mean? And it would also be interesting to see, if I didn't feed in every single ticker, would you get the same result? Would you probably get lower? I don't know. You'd have to kind of play around with it. I mean, I'm going to kind of play around with it too and see, what happens if I do pass through maybe just one or something like that. Or is it something too where it's going to kind of change a little bit if we just leave everything like that. So pretty interesting stuff. Okay, so now that we've done that, we're going to talk about our classification report. So our classification report is basically looking at just a couple of different metrics that we might use to kind of better understand how our model performed. And so for our classification report, there's a few different components that it does return back to you. Some of these are actually not right here for you, but we'll kind of talk about it when we get there. So the first one actually isn't well, it's there, but we'll kind of talk about that. But it's accuracy, so accuracy is there. So that's just measuring the portion of all testing samples classified correctly, and it's defined as the following. So true positives and true negatives. And so out of all the testing, out of all the classification points, how accurate was it? How often did it correctly classify samples? Recall, also known as sensitivity, measures the ability of the classifier to correctly identify positive labels and is defined as the following. So it's true positives over the true positives plus the false negatives. So the recall is intuitively the ability of the classifier to find all the positive samples. The best value is 1 and the worst value is 0. We have specificity, if that's how you say it. This measures the classifier's ability to correctly identify negative labels. So it's kind of like flip-flop from recall a little bit. And then we have precision. Precision measures the proportion of all correctly identified samples in the populations of samples, which are classified as positive labels and is defined as the following. So it's true positives over the true positives plus the false positives. And so the precision is intuitively the ability of the classifier not to label as positive a sample that is negative. The best value is 1. The worst value is 0. So you want that to be higher. So, generally you look at accuracy. If accuracy is good, that means our model is correctly classifying terms. Sometimes when you're looking from model to model, it's a little bit more challenging. Because you may have a model that has low precision or high recall. It's difficult to compare these two models. So what we use instead is something called the F-score. So the F-score helps to measure recall and precision at the same time. It uses the harmonic mean in place of the arithmetic mean by punishing the extreme values more. So it allows us to look at two models in comparison. So if you're trying to say like, well, which one did better? You can use the F-score. Now, in this case, we're not comparing it to anything else, so it's not really useful, but it's good to know it's there if you do need it. Okay, so part of it is we do need to create our classification report. And so what we're going to do here is, again, this is a metric that we can import from sklearn. And so it's the classification report. We need to specify our y true, and that's just equal to our testing values. So those are we know those are the correct one. And then we need our prediction values. Well, the prediction values are the ones that we had predicted using our training set. The target name is just the down day and up day. So this is just making it a little bit more interpretable. And then an output of a dictionary is true. That's because I want to put it into a pandas data frame, which I then transpose for just a little bit more readability. And you can see, so we have recall, precision, F-score, and then support, and then we have accuracy, macro average, and then weighted average, and stuff like that. So again, it's just more information for you to kind of interpret, and it's kind of slicing and dicing it maybe a little bit differently, or just making a couple adjustments or things like that. So it's there, but it's just kind of more helping you in a sense to kind of interpret what the model is doing. And so again, a lot of it's we kind of explained up here. Again, ideally you're looking for that accuracy component, but it also kind of depends on the problem too. Sometimes accuracy is way more important, but then other times, maybe precision's, a little bit better, what we're more concerned with. So part of it is really the problem at hand and kind of understanding what's all there. I'm going to check the time really quickly. Yeah, I'm going to call it off at this point. So in our next video, we're going to keep evaluating our model a little bit, and we'll kind of maybe go back over and kind of explain more of how that model was working to a certain extent, and then understanding how we can improve it. So that's kind of the next portion, is going to be improving our model. And at that point, we're going to really start interpreting kind of what all those adjustments that we can pull and kind of how they might impact our model at the end of the day. But overall, our model so far has performed very well. There's nothing super crazy at this point that's, I would say, concerning. We've got a very good accuracy score. Again, you might get a slightly different number than me. It really all just depends when you're running it and stuff like that. So don't be surprised if you get a slightly different number, but it should be generally in the same range. So if you have any questions at this point, feel free to put them down in the comments below. Otherwise, we'll see you in video number 5. Let's talk to you soon.